Alright, so we're going to go ahead and continue with these exponential and logarithmic applications. These are all formulas that you should know, you've seen before, you've seen in this class, you've seen in Algebra 2. So let's just go ahead and go over what this is. So this is, if you have a word problem that says that you are investing money and you are compounding it a certain number of times, like monthly, quarterly, whatever, you're going to use this formula, okay? And if you are compounding it monthly, it'd be 12, quarterly would be 4, so that would go in for n, and you should know that. Continuous compoundings is when you have PERT, and then half-life, this is the formula for half-life right here, okay? And all of these p-values are just your start amount. The r is the rate, okay, in these two, and that needs to go in as a decimal. The t in these two is time in years. The t in this one is how long you're leaving it, and then half-life will be your half-life of whatever substance you have, and we'll go over that. Alright, so let's look at number 1. It says an investment of $2,000 earns 5.5% interest, which is compounded quarterly. After approximately how many years will the investment be worth $3,000? Alright, so this is my $3,000 is my final amount. So I'm going to say 3,000. First I'm going to write my formula up here. I'm going to use A equals P1 plus R over N to the NT because it says compounded quarterly. So I know what formula to use since it said that compounded quarterly. So my final amount is 3,000. My beginning or starting amount was 2,000. I'm going to say 1 plus. I've got to move this decimal over 2 places to turn it into a decimal that I can plug into my formula. So this would be 0.0575 divided by, the n represents how many times I'm compounding it, so that would be 4 times a year, so this would be 4, and then I would raise it to the 4 times, the t is what I'm looking for on this one. It says how many years will the investment be worth 3,000, and so I'm going to solve this, and I'm going to have to solve it by using a log. So the first thing that I'm going to do is try to get whatever's being raised to the exponent by itself, so that's this right here. So I'm going to get rid of the 2,000 by dividing it over. So 2,000 divided by, or 3,000 divided by 2,000, I'm just going to leave it as 3 over 2 equals. Now this right here will turn into a decimal. I'm going to go ahead and, since it's all in the parentheses there, I'm going to turn it into a decimal. So I'm going to plug this in. 1 plus 0.0575 divided by 4. And I could leave it like that. I want this to be as accurate as possible. I'm going to change it into a fraction, and you can choose to write either all of these decimals down or this fraction down. I'm going to write the fraction. So that is 1623 over 1600, and that's raised to the 4t. Now, this is an exponential equation, and so I need to rewrite this as a log in order to solve. So I would say this is going to be log base, shells down. So log base 1623 over 1600 of 3 halves equals 4t. And so then to solve this finally for t, I'm just going to do log tall divided by log small and divided by 4. So let's do that in the calculator. Log 3 halves divided by log of 1623 divided by 1600. Okay, I'm going to see what that is. That's this, 28.408. And then I'm going to divide that by 4. And so my answer would be about 7.10. If I'm rounding to 2 decimals, 7.1. And this would be in years. Okay? Alright. Number 2, it says a parent raises a child's allowance 20% every year. If the allowance is $8 now, what year will it reach $20? Now, this one's not one that says compounded or continuously or a certain number of times, but what it does tell you is that the parent raises the child's allowance 20% every year. Okay, so this is what you would do for this problem. I'm going to use the P1 plus R over N to the NT, and since I'm doing this, I'm raising it every year. It's kind of like I'm compounding that interest once a year. Okay, so every year is just one time a year. So I'm going to plug 1 in for n on this one. So I want to know what year it's going to reach 20. That would be my final amount. My starting amount is $8. I would say 1 plus, this would be 0.20, and remember I'm plugging 1 in for n. And so then I want to know how long that's going to take. Well, in the exponent, 1 times t is just t. And also right here, 0.2 divided by 1, you could just leave as 0.2. Okay, either way. So I'm going to go ahead and again on this one, solve it the same way. Try to get that by itself. So I'm going to divide by 8. So when I divide by 8, 20 divided by 8 is just going to simplify to 5 over 2. And so then I'm also going to, this is a really easy decimal to find, so I'm just going to leave this as 1.2. Okay, you could turn it into a fraction, but since that's a decimal that I don't have to round, I'm just going to leave it as 1.2. Okay, and so then I'm going to do shell snail, just like I did, write this as a log, so this would be log base 1.2 of 5 over 2 equals t. And to solve this one, all I have to do is log tall divided by log small. So log of 5 over 2 divided by log of 1.2 is 5 I would round this to 2 decimals, so 5.03. T equals 5.03 years. Okay? Alright, we've got 2 more problems. Okay, so this is a half-life problem. It gives us substance here. Oh wait, before we go on, if it had said for some reason right here, for some reason the child was bad and they didn't raise a child's allowance, they lowered a child's allowance. If you ever lower something like that, then what you would do to make sure that you would get this right is take this plus and you would change it to a minus. Okay, so if a parent lowered a child's allowance, you would minus right here instead of plus. And I think you may have one like that, one where the value gets lowered. So you just check that plus, turn it to a minus. Okay, so this is half-life. This is A equals P and then 1/2 T divided by HL. Alright, so protactinium-234, toxic radioactive metal with no known use. None of this really even matters, but I do want to know that it has a half-life of 1.17 minutes. So how long does it take for a 10 milligram sample to decay to 2 milligrams? So a 10 milligram sample is what I'm starting with for P. I want it to decay to 2, so that would be my final amount. And then I want to know how long that takes, so I'm going to look for T, and I know that the half-life is 1.17. And since that's in minutes, my time that I find is also going to be in minutes. So I'm going to go ahead and divide the 10 over, and so that would be 1/5 equals 1/2 T divided by 1.17. And then just like we did on the last one, I'm going to do log tall, log small after I rewrite it. So this is going to be log of 1/2 of 1/5 equals T divided by 1.17. And the way that I would solve this is, again, log tall, log small. So log 1/5 divided by log 1/2. That's that. And then to get rid of this 1.17 on this side, I'm just going to multiply 1.17 over. So I'm going to multiply by 1.17 since I was dividing. And so this is my answer. I'm rounded to 2 decimals, so 2.72 minutes. Okay, so T equals 2.72 minutes. And make sure you're careful about the units. Okay, your units again is going to be in whatever units your half-life is in. Alright, and then this is our final example, and again, all of these are on the worksheet, or I think they're on the Google sheet that I'm giving you, so if you watch this, you can just type in these answers. But this one says an initial investment of $200 is worth $315.24 after 7 years of continuous compounding. The 7 years of continuous compounding tells me that this is my formula that I'm going to need. Alright, so if I plug all this in, my final amount is $315.24. My initial amount is 200, e to the, I want to know what the rate is after 7 years, okay? So now, I'm going to go ahead and try to, e is being raised, so I'm going to get rid of the 200. So I'm going to take this 315.24 and divide it by 200. If this is a long decimal, it's not that long, so you could write it as this decimal, or you could turn it into a fraction. If you do, it's this fraction. I'm just going to write the decimal out on this one. So 1.5762. 1.5762 equals e to the, I'm going to write it as 7r. Okay, r times 7, same as 7r. And so now I'm going to do shell snail. And so this will be log base e. okay, or ln of 1.5762 equals 7r. And so all I have to do now is type this in, the ln. So ln, I'm going to hit second answer, so that'll give me this last thing right here, so I don't have to type all that in. And then last thing I'm going to do is divide by 7. So when I do that, this is my rate. So this would be 0.065. Now, if they are asking you for a rate, they're asking you for a percentage. So if I were to turn this into a percent, I would move the decimal over 2 places, and that would round to 6.5%. Okay, so that would be my rate. And then that's all of these kind of problems that I'm going to give you as examples. I think that should be enough. If you have any questions, just let me know.